We are 13 minutes late, but we are here, and we are here with you. And I am very, very sorry. I have no idea what went wrong there. I have absolutely no clue why we were happily chatting in a room with no go live button. So in the spirit of open science and in the spirit of sort of working on things collaboratively together, yeah, welcome to our work in progress demo call. And I'm very, very excited to meet and chat with Tim, Eleftherios, and Marlon, who are going to discuss their projects. They're really quite different projects, but they're all really exciting ones. And I'm going to just, like step down from my anxiety of not being able to broadcast. And I'm going to just let Tim tell us about Porcupine. So Tim, go for it.
Hi, well, thanks for having me. And indeed, my project is Porcupine. I'm Tim van Maalwyk. I'm a PhD student at the Donners Institute in Nijmegen. At least I was a PhD student because I just handed in my thesis 1 month ago. And one of the chapters of my thesis was the Porcupine project, which is basically a visual tool, a tool to visually create your analysis pipeline. And
oh, he's gone. Oh no, this is just not our day. Eleftherios, let us jump to. Oh no, he's back.
Oops.
He's back.
You're here. Good. You were gone for just a time.
Yeah, right. I noticed. I was just poof, gone. Anyway.
You're back. You were telling us about visualizing your analysis pipeline.
So Porcupine is a tool in which you can visually create your pipeline by just dragging and dropping modules that all represent functions. But let's go back historically. 5 years ago, I started with fMRI analysis in general, and I was just very annoyed with the way that analyses were structured. And I've got a programming background, so I just, as a hobby project, started programming a project in which you can literally like drag and drop modules and connect them to represent your data flow. And I kind of did that just on the side for fun. But then a bit more than a year ago at the BrainHack Global in Amsterdam, I was like, right, let's try and hook this up to an existing framework of MRI analysis. And NiPipe was basically perfect for that. Some of you might be familiar with NiPipe. Basically, it is just a layer on top of a lot of different MRI analysis packages. And that's what we hooked our pipeline to. So now let me quickly give you a short demo, and let me try and share my screen. Can I do that, you think?
Yes, I hope so. I mean, we're not
screen share. There you go. Share entire screen. Right, and now we get Inception. But apart from that, if you go to timvanmaalwyk.github.io/porcupine, you'll find, well, of course, a lovely porcupine, because I wanted just, well, to make it look nice. But basically what it is, you see some screenshots here already, is a couple of modules that you can drag and drop, and then automatically it will create the analysis code for you. So if you go to install, then you're automatically directed to the GitHub repository where the code is fully online, and you can directly install your Windows or your Mac version. And if you do that, then it should look like something like this. those that are familiar with NiPipe might recognize some modules here. And basically, this is a very simple pipeline already in order to analyze your data. The only thing it does right now is run FSL brain extraction tool. But the bottom line is that as soon as you press generate code, then here in this window, automatically you will see the pipeline that is just the script that you can readily run. Well, on the one hand, this is just very simple and easy to use for a novice in MRI analysis, but it's also very good, very useful for the more experienced people to well, set up analyses very quickly. But what I feel is most important about this is that it allows you to think more conceptually about the analysis, because you can just very easily see what's going on because you've got a visual representation. In order to use it, we made sure that we have, let's see, quite an extensive documentation as well, to, well, make sure that everybody can hit the ground running. Every part of the project is described, and we have nice interactive, sorry, the animated GIFs to help you out. Basically, we hope that this is going to be an easier way of creating your pipeline, but most importantly, also sharing your pipeline. Once, oh, sorry, now we've got a screenshot again.
You're coming back. You're coming back.
I was gonna stop the screen share.
There you go.
Right. So where was I? Right. We're hoping that this is not only making the analysis a lot easier, but that it's also going to be easier to just replicate someone else's analysis, because you can just copy the .pork file, load that up, change only the very first node in which your data is loaded, and execute exactly the same analysis on your own data set.
I love it.
Then there is one last thing, and that's a little bit, well, in depth, but I still wanted to mention it briefly. Not only do we create an analysis file, just a Python script, but we also create a Docker file, which is basically a very simple, minimal operating system that runs your analysis in a closed environment, which is an even better guarantee that everybody that copies the analysis has the exact same software and replicates your analysis.
Yeah, sorry, I kept interrupting you all the way through that to say how much I loved everything that you were saying.
That's right. That's quite right.
And I was a reviewer of one of your papers. I think took a really long time to get a review back, so I'm very sorry about that. That was
That's all right. Don't apologize.
That was not a great sort of collegiate practice, but I did love it very much. And I wonder if, so I'm really passionate about sort of communities and building people, contributing to communities and contributing to open source code. And we're going to hear about DiPi, which has a really fantastic community of contributors in just a second. But Porcupine started with you just kind of being like, we could do so much better at running our analyses. And then you got together with people at a Brain Hack. And I wonder, who else was it that sort of you consider to be core contributors to Porcupine? But also, who do you imagine kind of, it's quite a young project, it's quite a new project. So who do you think will like help to develop it?
So yes, you are absolutely right. It's quite young, and therefore we don't have that many contributors. And an additional reason is that the core is written in C++, which is quite, well, difficult for most people. So indeed, I started getting to know people at the BrainHack, Lukas Snoek and Thomas Knapen, and they helped me with the NiPy part because they're very familiar with that. Then after that, and basically that's the development over the last couple of months, I've been talking to the NiPy developers more, with Satra and Chris Gorgolewski, to try and well, see where this is going to go. And where it is going to go is basically a web application to reach more people. And I'm hoping that way also to get, well, some more contributors, because it would move away from the very detailed C++ coding.
Yeah.
And then on top of that, on the one hand, there is contributors to the actual application, but I'm also very happy with good documentation, and that is something everybody can do. And I'm really hoping that if this gets some traction, that people want to contribute more in terms of documenting how this is useful, because that's what's generally missing in neuroimaging, just well-documented tools.
Yeah, yeah. And I think some of the most exciting projects, and I'll shout out DiPy again, have beautiful galleries of examples of things that you want to do. And one of the goals of Porcupine is to really sort of make it so much easier to say, yeah, I want to do what that person did. And so I think that's a really wonderful answer.
Yeah, we have a gallery, by the way. So it's actually called Gallery, gallery section of our website, which shows a whole bunch of examples. Just a very simple example of a single node of loading in your data and analyzing it with a single module and writing out your data. But we've got everything as complicated as the entire pre-processing of FSL, the feed analysis. And we basically set it up such that people can also contribute their own analysis and put it in our gallery easily.
So I'm watching the time, and I'm going to have to sort of move on so that we only finish like sensibly late from us to our late. But is the best place to contribute and to find out more the GitHub repository for Porcupine?
Yes, it is.
Excellent.
And of course, you can contact me on my email address, which is also listed on the GitHub, or via the BrainHack Slack.
Yes, excellent. And we will make sure that that information all goes in the OHBM blog post that we'll summarize and have this video.
Perfect.
So Tim, thank you so much. That's really amazing.
Thank you very much for having me, Kirsty.
No, you're very welcome. You're very welcome. I need to do a little bit of, I need to stop Tim presenting, bring over, and I'm going to unmute you. And wait, can you say hello, Altharius?
Hello.
Yay, you're here. You're here. For everyone that's watching at home, Altharius was in like a totally different hangout than the rest of us, whilst we were all sort of struggling to join you on YouTube. So it's a real delight to say hello and actually be here. And you and I met quite a few years ago at Cambridge. And I think that DiPy started in Cambridge. Liana, you have your own lab now. So I wonder if you could tell us a little bit about kind of how DiPy started and, I don't know, so sort of where it's taken you.
Right. So from the previous speaker, that he was talking about pipelines. My focus is different. My focus and DiPy focus is on actual algorithms. So the idea is try to bring scientists from different labs and different places in the world who have invented algorithms to put them all in the same code base and making users' life easy. and making possibly also Porcupine's life easy, because maybe it will be easier to use that software because it's easier to maintain one rather than 1,000 small software libraries. So so we wanted to give also access to people that are not in the big labs, and they have innovations to share with the world, and help them a bit. That was also another of the major problems, and I think we're doing quite well now. The project is focusing on structural and diffusion MRI analysis, but now it's growing also in other areas. I had somewhere here an image of this.
Share your
this
screen
is, yeah, so let me share my screen. Give me a second. So share, and
there you are. Yep, that's Tim.
Yep, and so here is a picture of the universities that have contributors who contribute to the IPI, basically, and you can see that we have contributors from many places, both from Asia, from South America, North America, and so on. And here is an example of, if I move this a bit here, this is an example of the different algorithms we have in DiPi. This is only for the problem of modeling the diffusion signal. So if you see here, I don't know if it is big enough, these are already many algorithms. So all those are implemented natively in Python and Cython, and they are easier to read rather than reading C++ code. So also that shows another mission of DiPi, which is like make it easier for other scientists to understand existing code and learn from the successful code.
Yeah, I love it. And do you have any
Sorry, did I answer the question? There was something else.
No, this was where it came from. I wonder.
Well, it started in Cambridge. I was second year, I think, PhD student when I started this. I had an extreme interest for open source for very young age. Even when I was very early undergraduate, I was paying attention to the Linux kernel and other similar projects. And learning about open source. And then when I went to Cambridge, I met with Matthew Brett and Ian Emo-Smith, and they were very interested to see what we can do with diffusion MRI and Python. So I really got into this and focused on this area. And immediately from the first release of DiPi, we said this is going to be an open project, global project. This was very new at that point.
Yeah.
And I think we were actually the first diffusion-related project that were completely open to the community, that everyone can contribute from wherever you are.
It's wonderful. And who are your? So I'm really interested in the idea of sort of the overlap between like the users and the contributors. So do you have the picture that you just showed with all of those different algorithms that are involved in DiPi?
This is only for one part of DiPi, right?
Yeah, well, yes, good point. So do you try and have people, sort of contribute to DiPi who are then going to use DiPi? And are you or do you sort of try and build a tool for, let's say, new graduate students and trying to make like their lives easier so that they don't have to do all of the work that
That's a very good question. So initially we designed DiPi to be like a library, a software library that other scientists, engineers can connect to that library, like you connect to NumPy or SciPy, and then use these algorithms to do their own scripts in Python. So the focus of the project was more on the people who love to code, basically. And they are doing already MRI analysis. They're kind of like, let's call them the experts in quotation. Now we're moving a lot. Now we have funds, we have support, we have paid developers. So now that we have built the core library, we can now move to the people who are not necessarily programmers, like let's call them the end users. So we are interested in both communities, both the people who love to code and people who don't love to code so much. And they just want to run DiPy from a command line, or from a web interface, or from Porcupine, or from NiPy, or from
I think
web.
I think that the two projects are really different, but I think the sort of the similarity and what my sort of passion for open science and open source is this real desire to just sort of make people's lives easier, and you can concentrate on the thing that you want to concentrate on, and you can do the fun thing that you want to do, and you don't have to sort of get stuck down doing something that other people would be able to do really, really well. So you have paid developers now, which is I feel like that's like, you know, it's like a huge gold standard for any open source project to move from doing it on weekends.
We have paid developers, and we have also great support from Google Summer of Code. We fund students every year now. It's already third year that we fund students for GSOC. It's amazing. It's feels awesome. Good. I have to say, in the beginning, the first years, they were not so fun. I'm so happy. You know,
well, and I think you're right that you were on the real sort of like leading edge of bringing.
Python was not even popular at that moment, right? It was not even popular at that moment.
What? Like that long ago?
Yeah, that's back in 2008.
It's amazing. It's really great. You mentioned, so thank you so much, and we'll also have the links in the blog post, like I said, with Porcupine, so that people can find out more and get in touch and use DiPy and contribute and let you know what they think. But you mentioned Google Summer of Code, which is a really fantastic transition for me, because Malin is going to tell us about her role in Google Summer of Code.
Before moving, just one moment. I want to advertise something. Wait a minute.
Advertise away.
It's something very simple. Okay, just a minute. All right. Let me say this. Here. Can you see it?
Yep. BrainHack Global.
So BrainHack Global. I'm organizing one here in Bloomington in this May, and we will have a lot of fun with DiPy and workshops for Python and data analysis and so on. So
everyone should
be happy to join in. You know.
Yes, excellent. We'll make sure to advertise that. And you know, there are BrainHack Global events all around the world. And Cameron.
Yes. It will be more than 30 cities again this year.
Yeah, it'll be really, really fun. So Bloomington, Indiana.
And also one more thing. Okay, so two. Okay, so in DiPy right now we have many people contributing, but we don't have so many what is called alpha beta testers, people who test their data. Test the algorithms with their data and give us feedback. So if someone is listening or people are listening, be happy to join in and try it and give us feedback. Sometimes people are just shy. They're shy and they don't give feedback because they're afraid to maybe send an email. That's now we have a live chat room, so you can just write a single sentence, and that will do it, and then we get back to you.
And that's such a wonderful point, because just as putting examples into the gallery or writing any sort of helpful documentation, giving feedback to the developers to say, I couldn't understand what you said and I couldn't get this to work, is it feels like you're showing off how stupid you are, and it's really not. It's actually the most valuable thing that projects could get. So that is a great point to make, and I completely endorse it. Okay, let's go to Marlon. Thank you so much, and give me a second. I'm gonna make Marlon big, present to everyone. Okay, and then we just need to unmute you. Can you unmute yourself, Marlon?
Right. Yes, I could.
Yes,
so
you're here. Great. So tell me about your role.
Well, I'm sort of a lapsed researcher, you can say. I have a PhD in computational neuroscience, but right after that, I went to INCF, which is a global nonprofit organization that works to get people to collaborate better around neuroscience tools and standards and infrastructures. And I've been doing that for 9 years now.
Oh, nice. And well, I wish I could sort of just interview in like a whole section about like building up communities and how easy it is to have international collaborations, but I'm going to stop myself from asking all of those questions and ask you about what INCF's role in Google Summer of Code is.
Yeah, so Google Summer of Code, since we didn't officially introduce what it is a summer program for students who can write code and be paid by a generous stipend by Google instead of, flipping hamburgers or cleaning somewhere or something boring. So it's been going since 2005, I think, and INCF has been in it since 2011. And the idea is that all code that's worked on is open source code. And mentors are essentially volunteers. They get a token stipend, but they really contribute their time and their knowledge. And the students are usually computer science, or at least some sort of education with computer science in it. And typically they have had no contact with research or research software before they join. So we get a lot of really enthusiastic students that are interested in the brain, which is fun, which is great fun.
Yeah.
Because sometimes you forget that initial excitement when you've been working in an area for a long time.
Yeah. And I think there are 16 projects that INCF are sort of, what's the right word, sponsoring, hosting this year?
Yeah, well, it depends on how you define it. Right now in our project ideas list, we have 31 different projects, but some of them come from the same mentor group. So you might have the same group proposing 5 different branches, depending on which way the student wants to go.
Gotcha. And the application period is happening right now. I think it closes on the 27th of...
Yes, on Tuesday. So there are 5 days left. There's just enough time to, if you work really hard, to make a good application.
Yeah, and I have a project, the BIDS Starter Kit project with Dora Hermes and Elizabeth, who probably the 3 of us are sort of leading on, which is all about trying to get people up and running with understanding the brain imaging data structure. But there's lots of different projects within the collection, and I wonder if you have any sort of tips for anyone that's watching, any of the prospective students, on the best applications, or even not just the applications, but like the most successful summers.
I would say that the first step is always to talk to the mentors and suggest solutions that you think would fit the project, but that usually gives you quite detailed feedback. And I think of the students I've seen that have been most successful, they started talking to mentors early. They might have come to us already in February and then done little fixes on GitHub and written out their project once or twice and gotten lots of feedback. And also, I think the students who have been working like in close collaboration with mentors, who've had the contact several times per week, and also delivered something that can be actually useful and visible. We've had a few students who did their 2 rounds, the 2 times that you're allowed to be in GSOC, and who are then really good at like GPU and brains, which is apparently a really rare expertise.
Yeah.
So we've been able to find people internships otherwise otherwhere in the community, or we've been able to have them in as mentors on what used to be their old student project. So
that's so fun. That's so fun. So they like contribute a whole bunch one summer, and then a couple of years later they end up.
Yes, I especially like when that happens.
That's great. That's really great. I've loved the messages from the prospective students who've been interested in the BID starter kit, and I was on strike, which has lasted a really long time. So Dora and Elizabeth have been doing a spectacular job of interacting with them, and I think the most fun for me is seeing a combination of people with technical skills, but getting really interested in helping to understand the brain and supporting researchers. And even we actually have some people who are mostly sort of neuroscience or cognitive science trained, but who are excited to join in. And I think maybe the BID starter kit is particularly friendly because most of what you're doing is communicating and helping people who are sort of getting started in the BIDS ecosystem. But you can come, you just have to be enrolled in a program, right? You don't...
yeah, you have to be enrolled or accepted to be enrolled this autumn. There is a specific date, that's the cutoff.
Yeah, but you don't have to be a computer science expert in order to take part.
No, you should probably have a year or two of programming under your belt.
Yeah. And let me ask one question, which is one of the things that I'm really passionate about. And it's an interesting question because the Google Summer of Code is a remote mentorship program. And so people will be all over the world and will have time differences between the mentors, and they won't necessarily sit down with them in the same room. Does that work well? Are there any sort of particular like tips and tricks for students or mentors that you've seen as a sort of coordinator for all of INCF's programs?
It usually works well. We've had a few isolated situations where a student stops responding, for instance. And if they live down the street, you could just go and knock on the door. If they live 8 time zones away, it's much harder.
Yeah.
And also we've had exactly one instance where a student and a mentor didn't agree, and it was a fairly severe disagreement. But then we were actually lucky enough to have had an active co-mentor who could sort of step in and give a neutral third position. But usually it works flawlessly almost, or at least nobody complains to me, so I don't see any flaws.
Well, I'm really excited about it. I am going to bring Eleftherios and Tim back in because there was a question from the YouTube chat. And Malin, you can answer it too. But we had this question last time, and I think I didn't ask it. The question is, what is your favorite text editor for writing code? So Malin, do you have a favorite since you're the unmuted one at the moment?
No, actually not. I've been trying. There are so many. I mean, I used to use Emacs like everybody else uses Emacs, and then I didn't code so much for a few years, and then I came back, and there are like 10 seemingly good options. So I'll be listening to what the others say and trying to follow.
Amazing. So Eleftherios, let's hear what's your answer.
Look, because I have changed many editors like everybody else. So I've done all the VI Emacs thing and so on. And so because I'm teaching code, teaching others to code, what I'm using is basically Spyder, which comes with an Anaconda distribution for Python. And it's very easy. And for MATLAB users, it's very easy to do the transition. So I use that, and also use Jupyter Notebook for some part of the teaching too. So
nice.
So these two editors I'm using.
I like it. Tim, as the C++ advocate here, maybe you weren't advocating, but as a user, what's your favorite? I think you need to unmute yourself to answer. Oh, wait, I think, can you there you are. No, do it again, sorry. Try again.
Now, better?
Yes, sorry. So, what's your text editor of choice?
So I'm not very dogmatic with respect to editors in general. So let's draw it a little broader. Every problem has well, a specific solution. So I did for Spider. Well, clearly, if you want Python, then you need Spider. If you do web development, you're probably using Atom or something like that. So there is not a single best solution for such a general question, I would say.
But what's your personal preference?
I'm just saying I don't have a personal preference.
Oh, you don't? You really like switch it? Oh, I see. Sorry.
It really it depends on what I'm doing.
Absconding from
if
the
I'm
best.
using MATLAB, then clearly I'm using MATLAB editors. Just don't use Vi or Vim, and then you're fine.
Because then you'll be there forever. You'll just be.
Exactly. But for the rest, everything's okay.
So I'm going to come back to me, and over time we started late, and I'm very, very sorry for my mishaps on that, but thank you so much to the amazing guests. I really appreciate you sort of sticking with us and then telling us all about these amazing projects. I personally code in Atom and I like it a lot, or Notepad++ I used to use, but I completely agree. There are sort of different editors for different people. In fact, at the Alan Turing Institute, we run a data study group where we bring people together, and there's about 60 different researchers who work on projects with different industry partners for a week. And we actually have, as part of our code of conduct, that we explicitly do not discriminate against people for their race, their sexuality, their gender expression, but also we don't discriminate against the number of tabs that you have open in your browser or the text editor that you choose for your work. Marlon, let me switch to you just for, I can see in the chat that you want to just say a little quick word. I'm going to present to everyone. Are you unmuted?
Yes, now I'm unmuted. So I just wanted to say that if you have a small project and you think you could mentor a student over the summer, if you would like to be in next year's GSOC, you can either join up under the INCF umbrella, because we're definitely applying next year again, or you can just contact me and I can help you set up your own application.
Amazing. Thank you so much. That's really fantastic. And to everyone who's applying for DIPI, GSOC positions, good luck. That's going to be an amazing summer. For everyone that's applying to the INCF positions, they are also going to be really amazing. Personal thank you to everyone who's applying for the bid starter kit, but they're all really exciting.
Thank you for the invitation.
You're very welcome. Thanks, everyone. And
it was fun.
Bye.
Bye-bye.
Bye-bye.